Okay, guys, so today in class we were talking more strategically about how you solve these systems equations, not just with substitution, but also algebraically, and what's it mean. Last week we focused if there was just one solution, how would we substitute our one equation into the other to solve for it. Well, today we're going to look at what happens when algebraically sometimes those solutions don't make sense, and then what does that mean. So those our learning target was I can solve systems with substitution, identify if they have no solutions or infinite solutions. Okay, that's really what we're going to be focusing on all week, and this was the start of our entry task. So let's take a look at our entry task. So we had 2x plus 4 and 2x plus 7. Well, to figure out how many solutions it has, the first thing I need to do is figure out my slopes. So in this case, I have the same slope, so I have the same slope, but I have different y-intercepts, and if I had the same slope and different y-intercepts, that meant that we had no solution to that problem. And I knew that because the lines are parallel. So that was the answer. That was a terrible parallel, but no solution. You get the point. Okay? So that was our first one. Our second one was a little more difficult because we have this equation in standard form, which means we need to use the equation m equals the opposite of a over b, which in this case we would be at m would equal negative 2 over 4, so my slope would be negative 1/2. So I'm going to have the same slopes again, and then 8 divided by 4 is going to be my y-intercept, or c over b, according to that equation. So I'd have 2, which means I have the same slope and the same y-intercept, which means I'm going to have infinite solutions for that one. Okay? And then entry task 3, that was going to be one that worked out as just one solution. And what I'm really going to be looking for on your papers and on your work is that you use the substitution principles that we did last week to solve for those. So that's what I was looking for with those two, though, is I wanted just you guys to get used to always paying attention. Same slope, same y-intercept, same slope, different y-intercepts. What do those mean? Because it can save you a lot of work in the long run. So let's keep on moving on. Okay, in the Kahoot game, it was really a big Kahoot on how do we find our slopes again, just reminding us of that information because we're going to use those tools pretty extensively as we go forward. Okay, let's take a look at our phase notes though. Okay, basically, we were looking at what do we do if we have equations that would look something. Let's grab one here. Let's say we had an equation that looked like this: y equals negative 2 over 3 x minus 3, and we have y equals negative 2 over 3 x plus 4. Now, this is a pretty basic level equation for this, but when we're looking at our phase notes, our first step is going to be to make sure both equations are simplified. So phase 1 would be make sure both equations are simplified. Okay, let's make sure both equations are simplified. I'm going to make my point a little better there. There we go. Okay, there we go. Okay, so if I look at these two equations, they are both simplified, okay? I could also, if I wanted to, jump over into phase 2, which is, phase 2 is ID the slopes and the predict. Okay, so I'm going to take those two equations, I'm going to identify my slopes, and I'm going to identify my y-intercepts, and then I'm going to make a prediction based on what I see from that data. So our equations again was y equals negative 2 over 3x minus 3, and we have y equals negative 2 over 3x plus 4. So I have those two equations there, so I'm going to identify my slope and my y-intercept. Both of those are in slope-intercept form, so it makes it way easier for me to do this. So in this case, my slope is going to be negative 2 over 3 for both of these. So these are going to be my slopes. Okay, and my y-intercepts are going to be these guys. Okay, so I'm looking at a situation where I have the same slopes, but I have different y-intercepts. What that tells me is those lines are parallel because they're moving in the exact same direction out into space, but they're crossing the y-intercept at different spots. So they're parallel lines, which means there should be no solution. That's my prediction. Okay? Now, it's super easy when they're in like this. So let's go to our next phase, which our phase 3 tells us to solve algebraically to check. Okay, so I'm going to solve that algebraically to check my answer. So again, if I have these two equations, y equals negative 2 over 3x minus 3, and y equals negative 2 over 3x plus 4. Okay, I'm going to use substitution to solve that algebraically. And to do that, I'm going to just take, I know what y equals is for both of them, so I'm just going to take this equation here and plug it into that y. So I'm going to rewrite what I have as negative 2 over 3x minus 3 equals negative 2 over 3x plus 4. So I just took this equation here and I plugged it in to that y, and it gave me this equation. Okay, now from here, I'm just going to solve it based on what I have. So I'm going to move my 3 over to this side because, to be honest with you, I prefer dealing with positive numbers. So I'm going to add 3 to both sides. That goes away, and I'm left with negative 2 over 3x equals negative 2 over 3x plus 7. Now, to get all my numbers on one side and all these guys on the other, I'm going to move this x over by adding its opposite, and they both cancel out, which leaves me on this side of the equation 0 equals 7. Now, I'm done what I can solve algebraically. There's nothing I can do from here. So I have to figure out what that 0 equals 7 means. Well, that 0 equals 7 isn't possible. And if it isn't possible, there means there's no solution. Okay? So my phase 4 in my notes would be, I got it all the way down here to 0 equals 7, would be identify final answer. Okay, so in this case, 0 equals 7 is not true, therefore no solution. Okay? Therefore there's no solution. And that's what that means. If you ever get to the end and your x's cancel out, okay, and you're left with something that equals like 0 equals 7 or 2 equals 5 or whatever it is that doesn't make sense, it means it's not true, so there's no solution. Okay? Now, we're gonna do the exact same thing we just did, except we're practicing a little more. So on yours, you're just identifying what it would look like. So to find the slopes of these two equations, well, I know that's my slope here, and my slope here, because that's in standard form, is always equal to negative a over b. This is your a, b, c. So that would be equal to the opposite of 3 over 2, and then my c is always equal to c over b, which in this case would be 6 over 2, which is 3. Okay? Now my slope here is going to be negative 2 over 3. So I found the slopes. So how many solutions am I going to have if I have different slopes? If you have different slopes, you always have one solution. Now I'm not asking you to solve these. I'm just asking you to know there's one solution for this. If I did ask you to solve it, you would use substitution. We would take this guy and we'd plug it into that y, and then we would just solve like we've been solving all last week. Okay? Let's take a look at this guy. It says, Mr. Robbie attempted to solve the following problem. What does this final solution mean? Okay? Now this is the opposite of what we just did in our phase example, right? I solved everything down algebraically. My x's ended up canceling out, and I'm left with 2 equals 2. And if that's the case, if I'm always left at the very end here with something that says like 2 equals 2, okay, if you think about it, when there was one solution, I always had an x equals something or a y equals something. When there was no solution, it made no sense. So if it 2 equals 2 and it makes perfect sense, that would indicate that there is infinite solutions. That's what that means. Okay, it means in this case, and if we actually simplified this earlier and we went through our notes, like our phases, and we actually simplified down to where we had this on both sides of the equation, we'd see that we have the same slopes, the same y-intercepts, which means we're going to have infinite solutions. Okay, so you're going to solve the ones that show up as we go through these. Solve the ones as we go through these. You're going to solve this one and put it in. And then that was your exit task for the day. So make sure if you're doing this as a makeup assignment that you do this exit task on a separate sheet of paper and turn it into me, and that will flag it so I go check your work so I can get your points. Other than that, that's what we've got working today. Thanks for taking the time to watch this, and hopefully you got through your makeup work.